atmosphere on our planet. But the thing is, even though there's only one atmosphere on Earth, the weather isn't the same all over the world. There are many different factors that can change the atmosphere in a certain area, and together they determine what the weather is like from 1 minute and from one place to the next. These factors include temperature, humidity, wind speed and direction, and lots of other things. But when you're talking about the overall weather patterns from a certain region of the world, you're talking about the area's climate. Weather is the minute-by-minute changes in the atmosphere. Climate is what the weather is like over a long period of time in a specific area. Now,
go back. That was great. Look at all that information that she just put out there for you.
Yes.
Write it down. Weather is the minute-by-minute changes. Ready? Not quite? Okay. All right, we're going to keep cruising.
Specific area. Now, the weather is constantly changing all the time, every day. Think of the weather as being like that one friend of yours who can never make up their mind about what movie they want to see or what restaurant they want to go to. Just because it's beautiful and sunny outside when you wake up, that doesn't mean you won't need an umbrella before the day's over. And raining is just one of the things that weather can do. Rain, of course, is just a form of precipitation or water that falls from the sky. It happens when droplets of water in the clouds, or sometimes ice crystals, get heavy enough and fall to the ground. If they're crystals, the warm air near the ground will melt them as they fall, forming liquid raindrops. But do you want to build a snowman? Another common form of precipitation is snow. Snow is just ice crystals that don't melt into liquid water as they fall. Another snow-like form of precipitation is sleet. It's what happens when ice crystals fall toward the ground, partly melt, and then refreeze again. But other kinds of weather can be way more severe, and the most common kind of extreme weather is a form I'm sure you're familiar with: thunderstorms. A thunderstorm can happen when strong winds make drops of water and pieces of ice collide and break apart inside a storm. This causes electrical energy to build up, which creates a little something called lightning. But all of this rain and snow and sleet I've been talking about, that's all just weather. And while weather can change in a few hours, a region's climate takes hundreds, thousands, even millions of years to change. So how can we better understand the difference between weather and climate? How about we send Cartoon Sabrina on a little imaginary trip for a month? Okay, here she is at her destination, Yuma, Arizona. Let's pretend it's the 5th of the month. On this particular day where Cartoon Sabrina is, it's warm but very cloudy and the light rain has been falling on her, sorry me, all day. Since clouds and rain are what the atmosphere has to offer on this particular spot at this moment, and they can go away at any minute, those conditions are, the weather. Now let's fast forward to the 10th of the month. Hello, sun. Looks like Tiny Me won't be needing an umbrella today. How about the 15th? More sun. The 20th? Still sunny. The 25th? You guessed it. Sunny with a chance of, well, sunny. And finally, on the 30th, the sun's still shining. Little Sabrina, I hope you packed your sunscreen. So what does this quick time lapse of a month in Yuma tell us? It tells us that Yuma, Arizona is a pretty sunny place. In fact, on most days, it's one of the sunniest cities on the whole planet. So the city's weather patterns existed before Mini-Me arrived and will continue after she leaves. In that case, you could say that Yuma has a sunny climate, even if its weather on a certain given day happens to be rainy. Now you know that weather is much more than just temperature. It's the condition of our planet's atmosphere, and it's constantly changing. You also know that weather and climate are not the same thing. But I saved the extreme stuff for last. The severe weather stuff, that is. You'll have to tune in next time to learn more about tornadoes, hurricanes, and blizzards.
All right. So, sometimes I feel like, we're watching this little kind of goofy video and blah, blah, blah. But I hope that at least in watching that, you can kind of relax your brain a little bit so that the definitions and the content can really get in there. Is that okay? So hopefully you've got now a picture between weather and climate. We're going to just make sure that our notes match what we want it to be. So weather is whatever's happening on the specific day. And what else did she say? You guys wrote it down, but I didn't get to write it down up here. It changes minute by minute. Whereas climate is a range of temperatures in a given area. Is there anything else that might go into a climate besides temperature? Did you just put your hand up? Okay, like you did, but then you changed your mind. Okay. Anything else that you can think of?
It takes hundreds of years to change.
Okay, it can take hundreds of years to change. Absolutely, absolutely. Question: if a place is hot, does that tell you everything about its climate? You're gonna say something else. Go ahead.
Isn't this about like the equator, like closer?
Okay. So absolutely, some of it can have to do with where you're at on the globe relative to the equator, right? Does that make sense? Yeah. So absolutely. So like the distance from the equator can absolutely have something to do with that. If a place is hot, does that tell you everything about the climate? So Yuma, Arizona is hot. Okay. What about the Amazon, like near the Amazon in Brazil? Is it hot there?
It could be.
It's really hot there. Tell me, do they have the same climate in Yuma, Arizona and near the Amazon in Brazil? No. What else is different? Well, what's different between the two? The humidity and the precipitation, right? That's the other thing. So it's a range of temperatures and precipitation or humidity. And we're going to talk about those two things today. That's why I wanted you to add that down. So if you don't have that written down, go ahead and write it down right now. And then if you have not pulled your green sheet out, that is to be pulled out right now. I am going to come around right now to give you a score on that because you should have that done at this point. What I would like for you to do is to take the moment that it's going to take me to run around here to check with your table mates, answer those questions if you have not done so, because we are going to discuss it in just a moment. Quick. All right. So with your table, you discussed a little bit of this. So you guys have your graph, daily weather over all of those years, right? So are we talking about weather now? Or are we starting to kind of build up a little bit more information? Does that make sense? We're starting to build up daily information about each of those different weather patterns, right? What'd you guys say in our class? Which was the most common? Orange, which is what? I don't know.
Cool and rainy.
Cool and rainy. Okay.
It's warm and rainy.
Warm and rainy, okay. Now, was it the most common by a lot?
No, actually
Well, I
not.
only like
What was the percentage?
20%.
Oh, okay.
Blue was 19%.
Okay, so it was warm and rainy, but not by, like, we can find the top one, right? But by a lot, not so much. Do you think that this is enough information to determine the climate of the area?
I would say so.
I hear some yeses and hear some nos. Can somebody give me a yes or a no and a reason with that? Yeah.
Yes.
Who?
Go ahead, Cindy. I'm going to call you next. What did you say? Beth, you were arguing, or not? Yeah.
I said yes because I have data from over the years that it gives like it's not a lot of data though.
Okay. So not a lot. Okay. So you're kind of on the fence.
Yeah.
You're like just a little bit over on the yes side, but you could kind of be persuaded either way. Let me go ahead.
I said no because the graph on number 4 had 1,000 years and we don't even have 100 years.
So there's not enough So the graph down here, this is the one you're looking at, has thousands of years. Did you guys notice it's like 200,000 years? Like that's a lot of years. Whereas we had what, like 20 years or something? Like not a lot. So I think that's a good statement, right? Like it's kind of a lot, but it's not like overall a ton. And we don't have a very strong, like, you know what I'm saying? Like it's not a super strong statement. Yeah. Question 3, would this amount of data be enough information to see shifts and changes? Not really. We would need hundreds of years, right? Or thousands of years worth of data. So I'm going to say no. This is not enough. So even if we had all of the data that you guys put into the form and we tried to graph it, we're not going to see a lot of big change there. Graph 4, or question 4 says, look at the graph. What is this trying to show us?
Ooh.
Bless you.
The change in tempo over thousands of years.
Thousands of years, right? Change in tempo for thousands of years. And so you can see that there was a spike here. And then it goes down, 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 down. And there's a spike again, right? Yeah, so you can actually see significant change in the temperature over that many years. Circle the areas on graph 4 that show the warmer climate. We kind of just pointed them out. Warmer climate here, warmer climate here. So this is kind of interesting because part of what you guys were arguing was that our data didn't tell us a climate, but really over this hundreds of thousands of years, not only can we figure out the climate, but what also can you see in this graph? Is the climate constant?
It is not.
It is not. So you can see both climate and the changes in the climate from this graph. Right. How do we see those shifts? What are you looking for? What are you looking for in this graph? Question 6. How is it that we're able to see shifts in climate? Hayden, what did you guys say back there? How is it that we're able to see shifts in climate with the graph from number 4? Elena, what'd you guys say?
I said the spikes in the graph and the labels.
Yeah. You see those spikes? You see like that they go up, 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 and then this like here kind of goes down, 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 and then it goes up, and then it goes down. It's just the change in those kind of averages, right? Yeah, the changes, the spikes, okay, the averages. These are the skills, my friends. I really want you to know this. I want you to know and understand this and appreciate it. These are the skills: reading graphs, understanding graphs, and being able to get this information. This is the kind of stuff that I want you to be able to do. 5 years from now, 3 years from now, 12 years from now, this is the skill that you need to have. Whether or not you can tell me the difference between weather and climate when I meet you on the Ped Mall, right? Like, oh my gosh, it's been so long. Tell me the difference between weather and climate, right? You might not be able to do that. David's like, oh man, I'm not going to look forward to that conversation. But I guarantee you that when you take the ACT, you will be asked to look at a graph that you have never, ever seen before. Over content that you probably have never, ever heard of before. Like some weird microbe that lives at the bottom of big ponds. Like, who knows about that? Well, some biologist does, right? But there's going to be a graph that you have to be able to read and understand. And here's the thing, you guys. You have that skill. And you're learning that skill right now. Do you understand what I'm saying? Okay? I want you to learn how to do science, not to have everything memorized. Okay? Okay. You can go and put that green sheet away. If you did not finish it, I would strongly encourage you to, if you have not already. I am going to score this for just a couple points, as I will with the next thing that we're going to do. You need to make sure you're doing your homework when I give you homework assignments. I will write one in just a minute. Yeah. What? is what in the grade book? It will be. It's not. I mean, I literally just measured it. No, because we just went over it, so that's not it's not a yellow sheet thing. Sorry, yo. Okay. All right. Will you send the person from your table that has a birthday closest to today, forward or backwards, so if your birthday was yesterday, you're still up, to get a green sheet and a white sheet for every person?
Where are you? Yeah.
God, I hate birthdays.
You will need one of each for each birthday. Well, don't worry about color pencils yet. All right. So, ladies and gentlemen, my friends, my scientist friends here, we are going to start looking more carefully, not at weather, but at climate. Okay? Scientists divide the world's climates into several different types or climate zones. This is what we were starting to talk about in our capture question. We are going to do some graphing today. As I said, graphing is one of those big picture science skills that I want you to understand, okay? And in doing so, we're going to look at some factors that help us determine our local climate by looking at, and we said this before, but here it is so you can underline it on your sheet so you don't forget it. Temperature and precipitation in 3 cities in the U.S. Okay? So I want you to understand what we're going to do first, and then I will let you graph, because that's what most of today will be. Part 1 is to graph the data. So we're going to use the data to create 2. So I need you guys to listen, because if you're not listening now, you're going to screw it up, and then you're going to be sad, because you're going to have to start over, and then you're going to be even sadder. And we don't want that, right? We want you to be happy people on a beautiful Monday. So listen carefully. We're going to make 2 separate graphs. The white piece of paper you have has 2 separate graphs on it. Do you see that? Okay. The first one will be month versus temperature. That's on one side. It says temperature on it. You guys see how one side says temperature? The second is month versus precip for each city. Okay? Now, here is the kind of potentially overwhelming part, and I want to make sure you get this. Okay, so you've got 2 graphs, and each graph is going to have 3 lines on it. Okay? So we're going to have 3 lines on each graph, 1 for each city. So once we get our axes set up, we're going to do axes together to make sure everybody understands that. Then you're going to send somebody up to get 3 different colors, and you will choose the colors, and you will color in these boxes. I'm just showing you where they're going, okay? So you have 3 different colors to graph, okay? And remember, 2 graphs. So we're going to put temperature for Cheyenne, Wyoming, for San Francisco, California, and for Des Moines, Iowa on the temperature graph. Are you with me there? Then, on the back, we're going to graph precipitation for Cheyenne, Wyoming, San Francisco, California, and Des Moines, Iowa over that year as well. Okay? Not super scary. Like, you can handle this. I know you can do it. And then after you've gotten the graph done, then we'll start to do the analysis. Let's get started with the graphs, okay? So you're going to have both of the things sitting out there together. I'm going to work with you. We're going to do the temperature axes together, okay? So temperature axes together. I think I put these on here. Oh, stinkers, I didn't. Hold on just a second. Let me see if I can find them. I thought I had it, but I did not. Silly me. Let's see. What causes climate graph? Go team. I don't care that my margins are small. Make it. Do it. There it is. Oh no, it like really didn't work. That stinks. Okay. Ah, rats. Okay. Well, we'll pretend. We'll make it work-ish. Okay, so here are the temperatures. We're doing temperatures over years. So what's going to go on the bottom?
The months.
The month. So let's go ahead and label that now. I would encourage you to do the labeling in pencil in case you make a mistake. Pencil is so much easier to erase, and you don't have to color things out, scribble things out. So I would strongly encourage you to use a pencil. Here we go. So we're going to put months on the bottom. And that's actually the label or the unit. This is really time in months. Okay? And then we're going to go ahead and label them. So we'll do January, February, March, etc., right? So go ahead and label your months. We're not doing a bar graph, friends. We're not doing a bar graph. We're going to do dots, 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 dots. So each month needs to be on a line. Okay? This is why we're using pencil in case you messed up. So January, February, March, April, etc., all the way across the bottom, the horizontal, the x-axis. Okay? Give you just a minute to finish that part up. So that part should have been pretty easy. Yeah, is that okay? What values are going to go on the y-axis, the up and down axis? Temperature, right? Now mine got a little bit funky because of the way it printed, and I apologize for that. We need to figure out how we're going to spread out because, and I've said this to you before, and when you take biology and when you take chemistry and when you take physics, your teachers are not going to fool around with this, which is why I want you to understand it now. Okay? You are going to go into those science classes and they will expect you to know how to set up a graph. So I want to make sure you understand it now. So here's the thing. I do not want you to just use the data or the space up to here and then leave all of this blank. Are you with me there? We want to use all of the space. Okay? So the first thing for us to do is to figure out what range we need to fit. You're going to do that by looking at your data. So you're looking at your green sheet, looking at the temperatures. I want you to find on all three of your locations the highest temperature and the lowest temperature and circle those. It doesn't have to be the highest and lowest from each location, the highest overall and the lowest overall. Go ahead and find those and circle them. Check with your table mate. Interesting. All right. David, highest temperature you find. What was it? 76. Where was that? Fantastic. That was a very succinct answer, and I appreciate that. It was in Des Moines, Iowa, so I know which chart to look at. In July. Boom, I found it, right? All right. And Jody, what was the coldest temperature you found? 20. And where did you find the 20 degrees? January in Des Moines. Awesome. Okay. So we need to go from about 20 to, let's say, about 80. Does that sound okay? So I'm going to just kind of note that in my graph. And I really, friends, I want you to understand this, which is why I'm going slow, okay? So we're going from 20 degrees to 80 degrees, which is a difference of how much?
About 60.
60 degrees. Okay. Now, my graph isn't quite the same as yours. So please, right now, I want you to count the number of little divisions you have going up the vertical side. Go ahead and count them.
Got 30.
Okay? Count them up. You counted them?
Yeah.
Cool. I'm going to have everybody else count too, just to make sure everybody agrees. How many did we get? 30? Okay. So we have 30 divisions. And we need to do that to go up 60 degrees. So the math here is pretty nice. It's not always going to be this nice, but right now it's really nice. If you have 30 divisions, you have 60 degrees. How much is each step going to be?
2 degrees.
2 degrees. So your label on your y-axis is going to be what? Temperature in degrees Fahrenheit. And then you're going to start at the bottom. Are you starting at 0?
No, you're starting at 20.
You're going to start at 20. So this one will be 20, 22, 24, 26, 28. Now, I will tell you that if you don't want to label every single one, and you want to go 20 and then 24 and then 28 and then 32, if you want to skip, if that makes your hand less sore, as long as you do it carefully, you are welcome to do that, okay? Or you can just count by twos. But because we did the math carefully, because we did it intentionally, you should be able to go all the way from 20 up to 40, and we'll be able to use this entire graph. We'll be able to use the entire graph, okay?
Pops.
Once you finish that, once you've finished labeling your y-axis, you can send one person from your table up to get colored pencils for everybody. Every person is going to need 3 colors, but you could get 6 colored pencils and then share, right? As long as you are sharing kindly, that should work. So come on up and get some pencils and go ahead and start your graphic, okay? You can use pen, but if you make a mistake, it's going to be a lot harder to get rid of it. Does that make sense? I'm not saying that you'll make a mistake. I just remember from last year that I had some of my lovely, lovely people who were just like, no, because then it looked really yucky, okay? And I just, often the people that want to use pen also want things to look perfect. So, okay? So you're going to get some colored pencils. Go ahead and start your graphs.
Yay.
So much.